Hi, everyone, and welcome to the AWS Nordics office hours, Ask Me Anything. My name is Gunnar Grosch, and I am a developer advocate here at AWS. And this is our show from the Nordics where we talk about AWS specific topics, be it technical or anything other related to AWS. As usual, on every episode, we have one specific topic to talk about. But this is, of course, very much about you, our viewers. So if you have any questions, just post them in the chat and we'll do our best to answer. And this week, I am joined by Specialist Solutions Architect for Containers, Andreas Lindh. So welcome to the show, Andreas.
Thank you, Gunnar. Thank you for having me. It's a pleasure being here.
Yeah, great for you to be here. Tell the viewers a bit about yourself, Andreas.
Yeah, sure. So, well, as you eloquently put it, my name is Andreas Lindh. I'm a specialist solutions architect for containers with AWS. I am based in. Oh, you can't see it behind me right now because I have my curtains covering it, but based in Stockholm, which is not very nice weather-wise today. I've been with AWS for roughly a little bit more than 1.5 years now, and thoroughly enjoying it. So yeah, that's me in a very short presentation, kind of short presentation.
Yeah, so during this hour, we'll get to know Andreas a bit more when we talk more about containers. And the topic for today is Kubernetes on AWS. But we'll get back to Andreas shortly. First, as usual, I want to show you our upcoming schedule, as this is a show we're doing every week, every Monday, 1 p.m. CET. So next week, we're going to talk about AI/ML with Vikesh. And the week after that, we also have an episode about machine learning. Then we move on to an episode about .NET on AWS, onto databases, cost optimization, and DynamoDB. So new topics every week, so join us every Monday. All right. So, Andreas, Kubernetes on AWS. Should we begin with what are the options for running Kubernetes on AWS?
Sure, we can definitely start at that end. Traditionally, or not traditionally, but before the launch of EKS, which we'll get into soon, customers, and I did this myself once upon a time, in the quite a while ago now, you'd had to install a control plane on a set of EC2 instances that acts as a minimum of 3, typically for production use, so that you have quorum within the cluster. And then you'd had to spin up your set of worker nodes where you actually run your workload, where you run your containers, your pods. That was the case up until 2017, when EKS was launched. So EKS, for those in the audience that haven't used EKS, is a Amazon Elastic Kubernetes service that allows you to use the EKS API to create that control plane, and EKS goes and provisions the control plane for you, to which you can then later on attach your worker nodes where you run your pods. And you have different options as well for what type of compute you want to use with EKS. And we're going to be focusing on EKS during the session. To be fair, that's what I'm going to show in the demo later on as well. So you can use either EC2 instances, so you can choose from all of the different instance types that we have available to you, or you can actually use Fargate. So you don't have to provision EC2 capacity, you don't have to maintain your auto-scaling groups attached to the cluster. And Fargate just provisions a new Fargate pod per pod that you schedule in your cluster. And then there's the middle ground, which is managed node groups. So you can provision your worker nodes on EC2 using the EKS API. And EKS then assists with automatically draining and circulating your nodes upon upgrades between versions and so forth. So right. That's a few different options that you have right there.
And we got a question straight away when we're talking about that. So what is the difference between OpenShift and EKS?
So OpenShift is a Red Hat product, and it's a superset of Kubernetes and I'm no expert in OpenShift, to be fair, but it adds things on top of Kubernetes. EKS is a Kubernetes conformant Kubernetes service. So how it came to be is that customers came to us and asked us, hey, we want vanilla upstream Kubernetes from the upstream project managed by you. We don't want to do the heavy lifting of running the control plane, setting up the control plane, upgrading the control plane.
All right. So and with OpenShift, there was a release during reInvent, last year's reInvent, which was the managed service for running OpenShift on AWS.
So Red Hat OpenShift on AWS, short ROSA, was announced, and it's for customers who want the OpenShift experience on AWS.
Right. So about the different Kubernetes offerings we have, there are, of course, news all the time. So it might be hard to keep up. So let's go through some of the new things that we've seen around Kubernetes on AWS recently.
Absolutely. And I'm not going to, I don't want to dwell too far back into time, but there was a few interesting announcements just recently. So looking back at the last 2 weeks, just last week actually, we did announce Kubernetes version 1.19 and EKS and EKS distro, and that adds.
Yeah, what are some of the news with that version of Kubernetes then?
Absolutely. So some of the highlights are that the Ingress API has finally reached a stable version or stable state. Also, pod topology spread. So, well, let me just explain for those who are not into the weeds of Kubernetes what the Ingress API is. So the Ingress API is effectively a way for you to define how traffic gets routed into your pods and into your services. And next API that reached stable status is pod topology spread. So pod topology spread allows you to define in your Kubernetes manifest how your pods will be spread across, for example, different availability zones. So you can configure your applications and your pods to spread equally over different availability zones instead of the default way in Kubernetes, which is bin packing and trying to couple, or not to couple, but trying to pack your pods as tightly as possible on the available compute capacity.
Okay, so we're able to perhaps more easily gain higher availability in our applications that way by spreading over different availability zones.
Exactly.
Okay, some other news then, Kubernetes news for AWS.
Right. Let me see where we have Gunnar on my screen. There we go. So another interesting piece of another interesting announcement in my mind is that let me see, when was this? This was 2 weeks ago, I think. Yeah, February 12th. We announced support for user authentication in EKS to the Kubernetes API with OpenID Connect compatible identity providers. So what this means is that prior to this announcement, you had to, for managing human access to Kubernetes, to EKS, you had to set up a mapping between IAM roles and role RBAC in Kubernetes. So creating role A for Team Gunnar that are allowed to read pods or create pods in Gunnar's namespace.
Right.
With the OpenID Connect support, you can now authenticate Gunnar not via IAM, but you can actually authenticate via that OpenID Connect provider instead. So you don't have to maintain that placeholder IAM role necessarily for human access.
And that basically means less heavy lifting. It's easier to, yeah.
Exactly. And using existing identity providers. So let's say you have in Gunnar's org, you have already, maybe use Cognito or maybe use Okta or Ping or something like that provides OpenID Connect identity provider interface, you can now use that to authenticate your users and your developers.
Right. And I think you have one more for us.
Yeah, and that's, let me just, I want to be, I want to get the dates right here, so just to make sure that I may be overstepping my 2-week limit a little bit. But on February 4th, we announced a new version of the AWS App Mesh Controller for Kubernetes. So the App Mesh Controller is the component that runs in your EKS or Kubernetes clusters, and it's responsible for injecting the App Mesh proxy, an Envoy proxy, and Envoy sidecar with your services. And that now supports MTLS. So MTLS allows you to have mutual TLS authentication and secure communication between services in your cluster without having to necessarily build that into your application code, because the service mesh handles that for you. So the little Envoy proxy that sits next to your container with your code is responsible for establishing connections and also breaking connections. So it acts as a little proxy.
And without diving too deep into App Mesh, can you just meshes?
Sorry, you broke up for just a little bit. I'm not sure if that was only on my end. Can you repeat that, Gunnar?
Okay. Yeah, without diving too deep into App Mesh, can you tell us what App Mesh is?
Yeah, absolutely. So AWS App Mesh is a managed service mesh offering that you can use with ECS or EKS or EC2. And why a service mesh? What's a service mesh? So a service mesh is effectively application level networking. So it allows you to control how traffic are routed in your cluster, and it simplifies how you implement cross-service communication without touching your code. So you can have that little sidecar proxy deal with routing traffic to version 1 or 2 of a service. So client-side control of that, and that's all controlled via a managed control plane.
Okay. So that was a few of the announcements we've seen around AWS and Kubernetes lately. Yep. So now let's move on to something fun. I think you have prepared a bunch of demos for us, Andreas. So
yeah, I mean, I saw Nicholas last week, so yeah. I had to do something, right? I had to have something visual to pique the interest of the audience.
And don't get me wrong, news on Kubernetes can always be fun, but I think demos are perhaps even more fun. So I think first off, we're going to talk about how to deploy an EKS cluster, and not only deploy it, we're going to do it using CDK, right?
Correct. Yeah.
Yeah, and I think most people perhaps know this, but what is CDK, and what is that compared to other ways of deploying?
So you're probably better off. You're probably a better person to describe exactly what CDK is, but I'll give it a try, and you'll keep me honest where I'm wrong. So CDK, Cloud Development Kit, is a tool, I guess you could call it. It allows you to define your infrastructure and cloud-based resources in a programming language that you are familiar with, and also use constructs and the mechanisms of the language that you are used to. And what it does is that it takes that code and it synthesizes it into CloudFormation. So what comes out on the other end of your Python, TypeScript, JavaScript, did I say Java? I think what language am I missing, Gunnar? We have support for a number of different languages in CDK. I'm going to use TypeScript for the demo because that's what I feel somewhat comfortable with. And it also provides pretty nice support in my IDE for auto completion and jumping back and forth between constructs and things like that.
All right. So where do you want to start, Andreas? Should we start screen sharing straight away, perhaps?
Yeah, maybe let's do that. And
there we go.
Did I miss something about CDK that you want to get across, by the way? I
think no, I think it's good. It's an imperative way of declaring your infrastructure compared to the perhaps declarative way of using CloudFormation, for instance.
And I'm going to go back to the whole what's new thing. But what's semi-new, on November 16th, the EKS construct library.
I think we might need a bit of a zoom
on
that one.
Yeah. Sorry. Firefox
even though people might have high-res screens today.
Sorry, I see. Seems like Firefox only zooms part of like per tab. So I prepped the other tab that I'm going to show, but not the one that is created. My bad. Apologies. So the EKS construct library graduated to developer preview and added support for CDKs back in November. And it's getting to a point where it's very much usable. So I've been playing around a little bit with it, and that's why I wanted to just show today what you can do using CDK when you provision an EKS cluster and create some add-ons. We can also speak a little bit on other options, but that's what I have prepared. So bear with. Should we just get started, or
yeah, I think let's jump into it.
Let's do it.
Ready to see console and code.
Perfect. So I have my little repository here containing my CDK project and also this K8s directory that we'll come to later. But first, let's start with what's in my CDK directory. So what I've done is that I've just, I've typed CDK init, created my app. That's how you scaffold out an empty CDK application. And it's pretty straightforward. CDK will look at my cdk.ts here and create a demo stack that I'm importing from my lib/Twitch demo stack construct here. So let's just, if my computer allows me, try to scroll to the top and see what we're creating. Just walking through it on a high level. I'm not going to try to dive deep on every single construct and all of it, but let's have a quick look. And my scroll wheel on my mouse is not working, so bear with as I click along and get confused at times. Anywho, and kind of showing a little bit what I think is nice with CDK. So if I'm going to run EKS, I need a VPC, right? I need to run EKS in a VPC. I need to create the subnets. I probably want my internet gateways. I want my NOT gateways and so forth. All of those networking constructs. Typically, if you do that with raw CloudFormation, that's a few hundred lines of YAML or JSON that you need to type out or find a decent template and modify that to your needs. With CDK, I think this is quite neat actually, is that I'm only defining I'm saying I want a new VPC that I'm going to call Twitch VPC, and I supply a set of properties. I've done this super like bare minimum here. I'm saying I only want one NOT gateway because I want to save some cost for my demo here. In a production scenario, would have a NOT gateway per availability zone. But this will actually create NOT gateways, internet gateways, a few subnets. We can go look at what it's actually created as well. That I will later be referencing in my code, so that when I create a cluster, I'm actually creating that in my VPC. So moving on to my console, if we go and have a quick peek at what it has created. I have my VPC here, and it should have created a couple of subnets. So by default, it creates two public subnets and 2 private subnets in reverse order here. I can also tell it to create subnets according to my specification as I want, with the certain set of sitter or IP ranges that are suitable to my use case.
Right.
Then I'm creating an IAM role to be used by the cluster. I'm not gonna dive too deep into that. I'm attaching a few policies. And finally, let's create our cluster. Or not finally, we're gonna add some more stuff after this, but in here, we're gonna create the cluster.
Just the policies you're using, those are managed policies.
Exactly. So these are managed policies by AWS. So I can just reference them by name here. So I want my VPC resource controller. I want my EKS cluster policy. Right. So not creating any policies with my custom actions and resource right now. We get to that in a bit, because that's something I do for another thing that we're going to look at. So creating the cluster, and here's where the EKS construct comes into play, right? I'm importing my EKS, CDK EKS construct, and I'm saying that, hey, I want a new cluster. I want to run my cluster in the VPC I created earlier. I wanted to use the role I've created up here, and I wanted to use, I started creating this before the 1.19 announcement, so I'm still using Kubernetes 1.18 here. For the purpose of the demo, I also decided to not add any capacity when I created initially in the cluster creation step here. I could have said, I want 5 nodes, or I want my default capacity type to be Fargate. But I decided not to, just to show how you can add that later and get a little bit more granular control over that. And if chat observes that I'm not a TypeScript expert by any means, that's because I'm not an expert by any means in TypeScript. That's not my where I come from. Next thing I'm doing right here. So I'm not using. We mentioned OpenID Connect support to authenticate humans. I'm not doing that. I'm actually managing my auth map using CDK here. So the auth map is a config map in Kubernetes that defines which roles have access, are mapped to what groups and roles inside Kubernetes. So either you could go and edit that YAML config map, or you could just use what I'm doing here. I'm using CDK. I'm on the cluster resource. I'm just saying add role mapping, and I'm adding my my role that I'm importing. This is actually an existing role that I have in my account. That's called admin. So that's what I'm logged in as. I've assumed that role in my account in the console, and that's what I'm going to be using for the demo. And I'm mapping that to a group and attaching a username. I'm also creating a role for my workers that I'll be using. It contains a bunch of, again, managed policies. It's just setting this up so that my worker nodes can, for example, if I want to send custom metrics to CloudWatch, if I want to use SSM to, SSM session manager to log on to my nodes, I probably want my Amazon SSM managed instance core policy attached and so forth, and also CNI policy and a few other things. Again, can be tailored to the needs of the user, of course. This kind of showcases another, what I think is pretty neat with the VPC construct in CDK, because I want to select my subnets, right? CDK have already found out and created a bunch of resources and subnets for me, but I want to have a variable here that only contains, or an array actually, we'll find out too, that only contains my private subnets. So using the select subnets method, I can, on my VPC, go ahead and pass on parameters to the subnet type, or let's see what's else in here. Filters, subnet group names, and so forth. I'm just making it simple and selecting all my private subnets created in that VPC. because I want to use that later. I want to use that when I'm adding worker nodes to my cluster, where my pods will actually run. So hence the selection here. I'm using a role, and I'm just saying max size, min size.
And that's the size of the node group.
Yeah, exactly. Sorry. That's the size of node group, and this will create a managed node group in EKS. Last thing before we go into these three is that I'm creating an OpenID Connect provider so that I can use IAM roles for service accounts. So IAM roles for service accounts, probably worth just touching on what that is and how it works is. You have multiple applications running on a single EC2 instance, right? And in the olden days, or prior to IAM roles for service accounts, you'd either have to scope IAM permissions to this instance, or you'd have to use a third-party tool such as KIAM or Kube2IAM or things like that. IAM roles for service accounts allows you to scope IAM permissions to your service, to a service account in Kubernetes. So service account in Kubernetes is a construct for well, you could say it's a service account, pretty straightforward, really. And you can then tell, hey, I want this pod and my service to use this service account to access, well, to gain access to AWS resources using IAM. So that allows me, long story, it allows me to scope down what different applications and components in my cluster can do on a service level instead of on an EC2 node level.
And using OpenID Connect.
Exactly. So we're creating an IAM OpenID Connect provider that IAM can use to authenticate the Kubernetes service account. And this is probably, going through all the details on how this works is probably worth a session in itself. And there's some great content actually on eksworkshop.com if people are interested in diving deeper, and also on the EKS documentation pages on how to set this up manually or how to set it up using EKS CTL. Right, so that's the things that I want and what I need initially, but I probably want to add a few add-ons because EKS, it gives you Kubernetes, it gives you our working Kubernetes cluster, but I probably want a few additional things. So what I'm creating here is we'll go into in time. We're probably going to just fly over the code in this section, but I'm creating a cluster autoscaler. So cluster autoscaler is a Kubernetes project that helps you scale your cluster, helps scale your compute capacity based on demand in your cluster. So what it does is that it sees that I have pods pending that I cannot schedule and run anywhere, and it goes and speaks to AWS autoscaling and requests more nodes in my cluster if it cannot schedule my pods. We can just quickly glance over what's in here. This is such a large font on my screen, so we'll be brief. What I'm doing here is to show how IAM roles for service account work, is that I am setting up a trust condition for my role, saying that this is the service account inside Kubernetes that will be allowed to use this role. And then I actually have a custom policy in here that defines, the overlays, that defines what cluster autoscaler will be able to do. So it will be able to say, describe autoscaling group, describe tags, and importantly, set aside capacity, and a few other things. And then finally, this is, the prerequisites I'm installing using, again, a very nice construct and a very nice method in the EKS construct called add Helm chart. So Helm is a Kubernetes package manager, and a lot of applications and add-ons comes packaged as Helm charts. So what I'm doing here is I'm saying, hey cluster, I want to add this Helm chart. I want to install this Helm chart in my cluster, and I'm just installing the cluster autoscaler, and I'm passing on a few values such as auto discovery of my worker nodes and my node groups based on cluster name. How I want to treat role-based access control for cluster autoscaler. Next thing I'm adding is LBC, AWS Load Balancer Controller. So AWS Load Balancer Controller is a Kubernetes controller that looks at Kubernetes services and ingresses and create load balancers in AWS based on what you define there. So we'll get back to how that works in a bit. I'm just gonna swing over it for now. Load balancer controller is installed in a similar way, just adding that Helm chart, and I've broken it out into separate files here for simplicity. And finally, the final thing that I'm actually installing on my bare bones cluster is external DNS. So external DNS is a project that allows, it also looks at services and ingresses and can speak to external DNS controllers. And in this case, Route 53. So later when we create a service, we want to be able to reach that by a certain DNS name. So we can specify that in our Kubernetes manifests, apply those manifests to our cluster, and the external DNS controller will go and say, hey, I don't see this record created in Route 53. I'm going to go and create it for you. And this is quite a long manifest, actually, because this is not packaged as a Helm chart. So this is just a conversion of the external DNS manifests into JSON for the purpose of using it in, or JSON-ish, or as a TypeScript object for the purpose of using it in with CDK.
A question to you then: is this something you've written, or more of a copy paste and replace with your information?
This is something that's copy pasted from external DNS. So if we go look at you can find all of this, and probably.
So for everyone watching, that even though it might look like complex code to get that working, you don't have to write everything yourself. You can reuse these.
And for whatever reason, again, scroll on my mouse is not working, so bear with us. I use my keyboard to go up and down. This is weird. So what I've done is just looked at the IAM policies required as defined by that project and converted that, as you say, Gunnar.
Yeah. So if you just joined us, this is the AWS Nordics office hours. I am joined here today by Andreas Lindh. He's a specialist solutions architect for containers at AWS. And we're looking at deploying a Kubernetes cluster on AWS or EKS using CDK, and going through what's needed to get that working.
Yeah, and a little bit more than what's needed as well in this case. Right. Yeah. To be fair, you could get away with less than what I've done here. Anywho, that's what's in my CDK stack. In the good fashion of a cooking show, I've pre-provisioned this so that our audience don't have to sit through and look at what's actually happening when CloudFormation goes and creates all this. If you're not familiar with CDK, I can just show you roughly what it does. So I can go ahead and do CDK synth, and that will actually synthesize my code into a CloudFormation template. We're not going to look through all of this, but just to show you what it does. And it creates all of these resources for me, my manifests, my custom resources, all of these things that I want in my cluster. I've then gone ahead and typed in CDK deploy and hit enter. And let me just make sure that I am default region equals E north 1 because we want to run this in Stockholm. So this is already created, so it's going to say, I'm not going to do anything because all of this is already there. And it will output, once done, the command to update my local kube config to use the appropriate role, and so that I can actually use kubectl to speak to my cluster. So if we look at the EKS console, I should have my cluster here, and I do. And we can also see that if you haven't used EKS in a while, there's been some fairly recent updates to the EKS web console. So you can now see your nodes directly in the console, which node group they belong to. And you can also look at your workloads. So which deployments you have, which daemon sets you have running in your cluster. So we see we have our cluster autoscaler, we have our external DNS, we have our load balance controller already deployed and running here, as defined in our CDK construct, CDK code.
And you mentioned that, and we saw in the code as well, that you were using 118. And I can see that there's a banner for updating straight away. So even though this was 119 was released, was it 2 weeks ago?
No, a week ago, roughly.
A week ago, yeah. And we're more or less straight away telling people that it's available and that you can update your cluster.
Absolutely. And I can go deeper into my configuration, and I can't scroll. This is frustrating. I'm not sure if it's why this happened during this time specifically. And I can actually go and look at my node groups. If I were to use Fargate for my pods, I need to create Fargate profiles. So a Fargate profile is a selector that defines, you could say, all my pods in this namespace should go to Fargate. And when these pods get scheduled, the selector will pick it up and it will schedule the pods on Fargate instead of the EC2 capacity. Right. That's just the things I wanted in my cluster to get started. And now we probably want to deploy some applications.
Yes.
Because what's a cluster if you don't have applications? So going back to my this scroll thing. Let me just see if I can how to navigate the tools you're used to in a way that you think you're used to when things break. In this case, something physical. So let's see if my touchpad. Yeah, there we go. Much better. Right. So in here, I have a bunch of manifests and things. And what we're going to do is we're going to use Flux version 2. So part of the GitOps toolkit to deploy applications as defined in Git. So GitOps is a way of declaratively declare your applications and the state of cluster in Git, and then have a controller in your cluster making sure that the resources in your cluster is exactly what you defined in Git.
And that makes sense. That's what we want, right?
Super straightforward, right?
Yes.
So
you mentioned Flux, and tell us about Flux.
So Flux is a project developed by Weaveworks primarily, and recently Flux V2, somewhat recently, was introduced, and it's reaching a quite mature state. So it's a set of controllers for. Let me see if I can just. Do I have my? And I need to zoom because for whatever reason Firefox only does this per tab. So it contains a number of different components. It contains source controllers, and it contains customized controller, helm controller, notification controllers, and image automation controllers. We're not going to go through all of this by any means. We don't have time for that today. In the demo, we'll be using the Git controller to define, here's my Git repository. That's what I want to use as the source for my state. We're also going to be using, I believe, if I recall correctly, I did this last week, so I should remember it, but we're going to be using a, no, we're actually using only Git repository source controllers, and then a Helm chart CD for a few things. Let's go into what I'm actually doing. And then we're going to hopefully successfully bootstrap my cluster based on what I have in my repository. Fingers crossed, demo gods hopefully obeys us.
I have faith in you, Andreas.
Excellent. So I have my repository on GitHub here. It's private, so unfortunately you can't go look at it right now. But it's the same things that I have in my Visual Studio Code here. So what we're going to do, let's actually go and bootstrap the cluster. So I'll be relying on my personal GitHub token, and I don't want to show that on stream. So I'm going to pull that from AWS Secrets Manager. There we go. And we're going to go ahead and I've installed the Flux CLI on my local machine. I could have done this using CDK or in that part of the provisioning step, but that kind of defeats the purpose of this demo and how you can actually interact with it and how it works. So I'm saying Flux, bootstrap, use GitHub as a source. Hanskli is my GitHub username, so I'm going to use that as the owner, and then specify my repository and which path that the initial specification where Flux will start looking sits in. So fingers crossed, this should connect to GitHub, clone the repo, install the Flux components, a bunch of custom resource definitions. And we should be off to the races shortly. While this is working in the background, we can start looking at what I actually have in my repository.
Yes.
And I think Gunnar is keen to get to a certain step in the demo that I told him about earlier. So what we're doing here is we have our Flux system. So Flux system defines like, here's my sources, what customizations do I want to apply. Actually, that's where you start, and then components. So that's the bootstrap of GitHub's toolkit and Flux v2. So it's an idempotent operation. So I can run it over and over because it actually committed its initial changes to my Git repository, which are these roughly what's in the Flux system folder here. I've added the monitoring part afterwards. Then I'm telling Flux to go look at my my customization here. So the customization file defines that use what's in apps.yaml. So I'm saying in/kate/apps/twitch. You should start looking, and you're going to use Flux system as the source repository. And here I'm again adding a few things. So these are my applications that I want to deploy on the cluster. And I have kubedoom. We'll get into what kubedoom is shortly. And I also have a demo 3-tier web application called Yelp. And in each individual folder, I have my base. So with customize, you define this is the base manifests, and then you can add overlays. So an overlay in production could, for example, be I actually don't have any super nice ways of illustrating what you can do here, I've just done it super simple, but you can change certain things in the manifest when you use customize to template out the YAML. So maybe you want to change an environment variable, or maybe you want to change something different depending on which environment you deploy your applications into, or on which cluster even. So this is super flexible and super customizable to your needs. So again, my production customization just says, hey, use my base here, and my base for Yelp actually defines a Git repository as the source, and it also has a Helm release object, and that Helm release object says effectively, hey, go look in my Yelp Git repository as defined here in this particular folder for a Helm chart, and go and install it on the cluster and use these services, these values to customize the Helm chart. So you can use values when you install a Helm chart to change the behaviors, change parameters and so forth. So using based on that, we have a hopefully fully bootstrapped by now cluster. So if we do, I have my kubectl aliased to k. So let's just do k get pods all. And hey, we have a bunch of things running in our cluster. It actually worked. The demo gods was on our side today. So I'm not going to go through what's in the Helm chart and all of what's in the Helm chart, but that Helm chart will create a, in the Yelp namespace, let's do get all. Resources have been created in the Yelp namespace. And we have a service, and we also have a target group binding for load balancing our application. We should have an ingress now. Yeah, okay, sure. It just didn't show when you do get all. So I have an ingress as well defined. So if I do actually Yelp ingress, that's YAML. It has templatized what's in my Helm chart and created an ingress where I define that I have a host set up. So what I want to show here is how external DNS, as we spoke about earlier, picks this up and creates a Route 53 record for us. So if everything worked out as it should, we should now have a Route 53 record pointing to Yelp. And we do. So if we go to that DNS record, we can actually access our application that was installed using the Helm chart in our cluster, applied using GitOps via Flux. That's a lot of things. It's a lot of things that we're flying over in a very short time. I'm aware of that. So sorry, chat, if it's a lot.
No, I feel that I'm unusually quiet this episode because I need to try to keep up with everything that's happening. But this is cool. So we've set up an EKS cluster. We've used GitOps to then install using Flux to install, was it 3 applications?
Yep. And this is one of them.
This was one of them. And this was, this is basically a 2-tier or 3-tier application.
Yeah, it's a 3-tier application. Let me show you the.
Oh yeah, so you had both a load balancer, database, and an application or the web
exactly. Okay, this is not the best. Well, this is roughly what the Yelp application consists of, and it's defined. So we have our UI, our app server, and we have a Redis cache and a Postgres database. So that's all deployed in our cluster. as individual deployments. This is just for demo purposes. You shouldn't run Postgres as a deployment in the way I'm running it in my cluster right now. I would probably use something like RDS instead. But again, just for the purpose of showing how you can use external Helm charts in your repository that defines what you want to run. So you can tie multiple repositories together in a GitOps fashion to deploy your applications.
And in this case, you did the deployment of it manually using Flux. But I suppose based on Git operations, you would then set that up for CI/CD as well.
So what would happen if I were to go and make a change in my code here? Say I want to add something or I want to remove something in the repository that defines what's running on my cluster, is that Flux will actually go and pull this repository for changes. So I can just go ahead and commit my changes, and Flux will see that oh, there's new changes, there's new things that I need to do with this based on what's in Git, and it will apply it for me.
That's cool. That's really easy way of getting started with GitOps.
Yeah. And using the different source types, you can also have it look at Helm registries and things like that. If you have non-Git things, like if you want to install this specific Helm chart from this specific Helm registry, if you have that in the organization.
Cool. So with me today on the AWS Nordics office hours, I have Andreas Lindh. We're talking about Kubernetes on AWS, and specifically deploying EKS cluster using CDK, and now we've also deployed applications into that cluster. We have 8 minutes left, so if you have any questions around Kubernetes on AWS, well, post them in chat, and I can see that we actually got a question right now. So let's put that on screen. Do you need to sidecar an RDS proxy to connect your app to RDS or anything like that?
No, you don't. You can connect directly from your application to RDS.
That's a straightforward answer.
Yeah.
So since we're running this in EKS, we have access to all the AWS native services.
Exactly.
And can use them. And then, of course, how you set it up depends on the specific use case. All right, so I think you have a last demo for us.
Yeah, I mean, who would I be if I didn't bring a little bit of chaos to your show, Gunnar?
Yes, I'm super happy for this.
So, we're going to introduce a different form of chaos today.
If people don't know, chaos engineering is subject really close to my heart. I'm a strong advocate for chaos engineering in any form, and Andreas is going to show us a different way of doing chaos engineering.
A different way of chaos engineering, I think. Yeah. So this little project from Storax, I'm not sure about David Zuber, is using I guess almost 30 years old now game Doom to connect to the Kubernetes APIs and show you different pods as monsters very intuitively. So as part of my manifest here, I'm actually again using not sure why I wanted me to change colors here. I'm actually using his repository as a source, and I'm using the manifest folder, where he defines, role-based access control, what the deployment looks like in the namespace. So Flux have applied and installed kubedoom for me in my cluster. So let's just verify that we have in our namespace called kubedoom, we can get pods. We have our game kubedoom game running. To connect to it, I need to use VNC so I can actually play the game. So of course, who would I be if I didn't run that in my cluster as well? So I have a web-based VNC deployment here called no VNC. I'm just let's see, where are we? We are customization. I'm creating namespace and the deployment. I'm actually introducing the other stuff here. So I'm just pulling in no VNC image and specifying where I want to connect. So let's do this. Let's in this. Sorry. And here, let's just watch what happens. kubectl get pods watch in all namespaces. This will show us how our pods are doing and how that changes as we start applying a little bit of chaos. And let me just get my connection details. So I want to access kube doom. So I'm going to forward my local port 7000 to, oh, sorry, I'm not. There we go. So if I bring up my Firefox and I resize that so we can see our pods over here. Got the local hosts. Let's connect to our game. Let me see what's the, I think I know this. Password. No, I don't want to send that login. So here I have my Doom game. I'm very bad at this game, so I'm gonna apply some cheats just so that we can get access to our pod monsters and go ahead and add the chaos. So I'm adding my sheet, and I have my big gun now. And the last thing I want to do I want to be able to walk through walls. So let's see where that sheet is as well. Not very competitive gaming, this, is it?
And the thing here is that we're running Doom inside the cluster.
Yeah, exactly.
And trying to find the pods running in your cluster then.
Now I can walk through the wall and I should be invisible, so I can see all my pods here. Not sure if it's visible on the screen. Oh, okay. Anywho, there's the pod names spamming up there. Yeah. So let's go ahead and shoot a few of them, and we can see that we terminated our one of the ELB-UI pods on the left hand of the screen, and terminated core DNS pod. And yeah, so this is just a fun little way of applying some chaos to the cluster. And I probably there we go. Bunch of chaos. I realize we're at 1358, Gunnar, so we're probably gonna leave it there.
Yeah. What happens if you kill the Doom pod?
Oh yeah, I've done that previously. Let's continue shooting our monsters here, and there we go. Now we got to get disconnect because the Cube Doom pod was terminated.
That was not highly available then.
No, it was just running one copy of that. So the LWAP should have continued working because Kubernetes will make sure that I had configured that it's going to run 4 replicas. So when one pod was terminated, another one would have been spun up.
Yeah. All right. Cool, Andreas. Thanks for the chaos. I always appreciate that from my guests. So time to wrap up. We've talked about Kubernetes on AWS today, and you, Andreas, showed us how to deploy a cluster using CDK, and then to deploy applications using Flux and GitOps. And to end it, a bit of chaos using Doom.
Cube Doom, yeah. You need a little bit of fun in the day as well, right?
Yes. So perhaps not something to try in production, but
no, I wouldn't encourage that at all.
No.
Opposite.
So thank you very much, Andreas, for joining us today. Andreas is a specialist solutions architect for containers at AWS, working out of Stockholm. And thanks everyone for watching. It was a fun show to do, and thanks for the questions and comments. And join us next Monday when we're back as usual at 1 p.m. CET. Thank you very much.